called string theory, in which elementary particles are excitations of energetic strands that are, it's like little strings that are being plucked in different ways, different modes, to produce particles. And the technical reason for that is because a lot of theories blow up mathematically if you put in 1/0, just like if you write in 1/0 to the calculator. So if a particle has a size of 0, then it won't, some of the theories won't work because you have to take 1 over the size. But if a particle has a small size, then you can put in a small number into your calculator and take 1 over it, and you actually get a good answer. So that's why, you know, very, very quick reason why researchers are looking at string theory. But string theory imagines that there are 10 or 11 dimensions of the universe, and they somehow became compact. They folded up like origami. So imagine you have an origami that's in 10 dimensions, and that you do some kind of folding, and that all but 4 of the dimensions fold up. Well, it turns out there's about 10 to the 500 possibilities for that folding, which is a ridiculously large number. But some are interested in using a multiverse of all these possible universes to explain why our universe is the way it is and has only one of those possibilities. And then finally, Einstein, in his early work, came up with this idea of a cosmological constant, which was kind of an anti-gravity term to stabilize the universe. When he didn't, before he believed in expansion, he believed the universe was stable. So he added an extra term to his equations to create a stable universe. But then when he found out about Hubble's observations of expansion, Einstein got rid of that term and said it was a great blunder. But then in 1998, 2 teams of astronomers discovered that the expansion of the universe is accelerated, and that cosmological constant term is a great way of explaining that acceleration. So here's kind of a chart. The red, the top line is how the universe actually is. Its expansion is speeding up. The other colors are what astronomers thought before that discovery would be how the universe behaved, either collapsing or slowing down its expansion. But we now that the universe is speeding up in its expansion. So cosmological constant seems to model that very well. But astronomy needs a small cosmological constant, just enough to give a universe an extra nudge in its later years to accelerate it in its later years. But we don't believe the universe was accelerating in its early years, because otherwise stars couldn't have formed if the universe